Hi everyone, and welcome back. We are working with our trig identities, the basic trig identities or the fundamental trig identities and the Pythagorean mostly, to simplify some expressions that are written in terms of our trig functions. And we are going to do a few more examples of simplifying, and then I'm going to do some proving, and we'll go from there. So this problem is we have the sine of x times the secant of x all over the tangent of x. And the way I like to approach these problems to make them easier for me, you can find your own process in as well by just, a lot of times, just starting in and trying something. You know, and if you start getting it to make it look uglier, just scratch it and start over. So we have the sine, which is the sine. Secant I know is 1 over the cosine. And I also kind of look at what I've got as I go. And now I'm kind of seeing already here that if I do sine times this, I'm going to get that tangent. So I'm not going to change this guy, because sine over cosine, which is what this is, gives me the tangent over the tangent, which is equal to 1. Of course, if you want to be very, very picky, we do have some qualifiers. We have to make sure that the tangent function is not 0, but we kind of assume that at the beginning. So these two are not completely identical. We can go back to when we were graphing, because if I graphed this one, we'd have some holes in it, or we'd have some asymptotes in it. And actually we'd have holes because it's equal to this function, it's equal to 1, except where all those tangents are 0, so we'd have a bunch of holes. But we're just kind of working with these right now, and I'm not too concerned about writing all those qualifiers on there. I'm more concerned as seeing how we can play with these identities. Let's do another one here. This will be our last simplifying, then we'll move on to the next process, which I find actually easier than this one, simply because I don't know where to go or when to stop sometimes. I mean, I can't go any further than 1, but sometimes you get an expression and you're like, well, can I simplify this further, or is that the best I can do? And sometimes it's a judgment call, and so that's why I like the other problems a little bit better. All right, so here there's already in sines and cosines, there's nothing much I can do. So the only thing I really can do is to get that common denominator and bring them together. So my common denominator would be multiplying these two guys together. So I'm going to have to multiply this top one by 1 plus sine. And I'm going to then and I'm going to do it all in one step here for you. Because my common denominator is going to be 1 minus the sine of theta, or alpha, sorry, and 1 plus the sine of alpha. And then I have my plus, and this guy I needed to multiply by 1 minus that sine alpha. Now you could have done a step in between where you'd have this guy over that, and then this guy over that, and then bring them together. That's fine. I do understand going this direction here, but I do want to see this sort of thing going on. The next thing I'm going to do is actually add my numerator, because we do have a positive and a negative, which will cancel, and I'm left with 2 on the top because I'll have that 1 plus 1. On the bottom, I'm actually going to FOIL that out. So I will have the 1, we'll have a plus sine alpha, and we'll have a minus sine alpha. And then we also have minus sine squared. So simplifying this, I'm left with 2 over 1 minus sine squared. My squared doesn't look very good there. I can again work with that Pythagorean and work with this guy. And the only reason I know this is I've been practicing this for a long time. It takes time to understand that I can go further. But that's because I've been practicing this over and over and over again, and I start to see the patterns, the little tricks, and all of those things. And I know that this 1 minus sine squared, because I do know sine squared plus cosine squared is equal to 1. So now if I moved this sine squared over, so I recognize the 1 minus. I could have moved the cosine squared over and had sine squared equals 1 minus cosine squared. So I recognize this to be the other term. And again, that recognition just takes time. And I guess we got alpha, not x, in our problem. And now over cosine, that is my secant. So this is actually 2 secant squared alpha. All right. The next type of problem that we're going to see, those were our simplifying problems. The next ones that we're going to see is when they tell us to prove the identity. So what they're going to give us, and here I'll have cotangent squared minus cosine squared is supposed to be equal to cotangent squared times cosine squared. And the process here is, we don't know that it's equal. So what we can't do is we can't cross that equal sign. So our job is to start on one side and manipulate it through like processes that we've done, simplifying it, to get it to look like the other. Okay? So we want to take one side. So we're going to work with either the right side or the left side, the right side or the left side, and we're going to manipulate it to get it to look like the other. Okay? To choose the side to work with, I look at the one that looks the messiest, or something that would be easy to simplify or change. Okay? And I think that if I have a subtraction problem, because there's like two pieces, I can bring them together to create one fraction if they're fractions. It's much harder to take a single and break it apart. So I'm going to start on this side. And my job through substitutions and things of that nature, or algebraic manipulation, legal applications of algebra, to get it to look like cotangent squared times cosine squared. That's my job. While I'm doing these problems, I always keep an eye on what this looks like. So in my head, I see that cotangent, I remember cotangent is cosine over sine, or 1 over the tangent. So I'm going to kind of keep track of that. So I'm kind of thinking I've got cosine squared over sine squared sitting here, and a cosine squared. All right, so here we go. Cotangent squared. Again, I like to go to everything 2 sines over cosines. Cotangent is cosine squared over sine squared. And then I'm going to subtract cosine squared. Okay, so all I've done right now is changed everything into sines and cosines. Now I have 2 pieces. I'm going to bring them together with a common denominator. My common denominator is this sine squared. So I need to multiply this guy by sine squared over sine squared, and then we're going to subtract. So I'm going to write that in one line like I've been doing. So there's my cosine squared times that sine squared, and this is all now going to be over sine squared. Okay. And I do want to remind you, I have been doing these for a long time. I'm going to say this many, many times through these videos. I've been doing this forever, seems like, since I was in high school, which is a long time ago. And so I know all the little tricks, and I can kind of know where I'm going. For you, it's going to take practice. You really need to practice. So I see that these both have a cosine squared in it. I also noticed that my answer had a cosine squared in it, so that's why I'm going to pull out that cosine squared. And then I'm left with 1 minus sine squared. Okay? And like in the previous problem, this 1 minus sine squared is cosine squared. So I'm going to replace it with cosine squared. And now this piece here is cotangent squared. So that is now equal to that cotangent squared, cosine squared, which is where I was, so we are done. So we have just proven that this, through lots of little steps, was equal to this. So we've proven the identity. I think I'm going to stop. 1, 2, 3. Nope, I'm going to do one more before I do the next video. So let's go and take sine, oops, nope, secant. This one won't take us very long. Times the sine of x is supposed to equal the tangent of x. And again, we want to prove the identity. So I want to start with the uglier side, the side that looks messy. Well, this has 2 terms, that has 1. So I'm going to start with this secant times the sine. I'm going to rewrite secant as 1 over cosine times the sine of x. Well, that's sine of x over cosine x. Oops, getting ahead of myself. And sine over cosine is that tangent. Sometimes they're simple and easy. Sometimes they are a little bit more detailed. I am going to stop the video here, and we're going to come back and do 1, 2, 3, 4 more of these proving the identities, so you can see a few more examples.